Hi everyone. I know you've missed me. I'm sure dearly. I'm sure your life is just not complete without seeing me every day yell at you guys. Mr. Zucker has been so nice to help me out here. He is going to be handling almost all the earth science stuff, using the lessons that I normally provide for you guys. He's putting everything up, helping me answer questions. I have to take over all the freshman classes, so I have a full load there, and I don't think I can handle like 200 students. So he's helping me out. So this is great. But I'm going to make a video every day talking about your assignments and making sure that you guys know what you're supposed to do. I'm also available during my office hours to answer any questions. That's from 10:15 or 10:30 through 11:15 each day. If you want to contact me on Google Hangouts, that's cool. We can set up another time to do face to face, and we can screen share, and I can walk you through. So today we're going to be talking about topographic maps. So topographic maps, normally we would start with a lab and you guys would do that and it'd be hands-on, interactive. You would build like a topographic map and stuff like that. Can't do that, sorry. So let's get through this. What you're going to be able to do today is you're going to be able to calculate the gradient and direction of stream movements and topographic maps. There's always one or two questions on the Regents about this. So if you master this today, that's an easy, free one or two questions points. First, let's start with gradient. You've done gradient with Miss Gang, like if you've been here or you've done it with another teacher. Like you've maybe heard of slope, something like that. That's what we're going to calculate today. So gradient is found, the equation for this is found on the very first page of the ESRT. So remember, you can use ESRT anytime. Like it's not a cheat sheet. Like it is a cheat sheet. It's a cheat sheet that you're allowed to use, so it's not cheating. It's on the very first page of the ESRT says gradient. It's a change in field value over distance. So we're going to talk about that right now. Calculating slope. Like for our first example, you normally will see like a picture, and it will have a whole bunch of rings. Those are called isolines. And so this is going to be talking about elevation when we're talking about topographic maps. So these isolines, the closer they are together, that means the steeper the slope. And then so you'll probably see two letters like on this map. You'll see like an X and a Y, or an A and a B. So that's basically what we're going to be dealing with now. So let's go through this. The next thing that you're going to see is some of the isolines have numbers on them. So let's say the very first example that you guys are getting ready to see is a 400. And then if you go down, let's see, 1, 2, 3, 4, 5. If you go down 5 lines, there is a 300 down there. So that means that every line is worth how much? How much do you think they're worth? So if 400, then you go down 5 times to 300. So each line is worth 20, okay? So that's how you would calculate that. It's just like sort of like a graph, like how you never, if you're doing the y-axis, you never put like 1, 2, 3, 4, 5, 6, 7, 8, 9. It might just go 5, and then it skips some, and then 10, skip some, 20. This is the same thing here. That's how you have to do this to calculate. So if we notice up there, the difference is the X is not on the 400. It's one below. So like what is the actual difference between X and Y and elevation, the change in field value then? So the 400 and then the X is actually on 380 and then the Y is on the 300 iso line. So 380 minus 300 is 80, okay? So that is the difference in field value. So now we have to look at the horizontal distance. So the horizontal distance is the actual measuring. Like we have to measure something from the X and the Y. So you can take a piece of scrap paper or anything like that, and you can hold it up, like just literally hold it up to this sheet on your computer, and you can just mark it off with like little 2 lines, and you can use that as a ruler. So you don't have to have an actual ruler. You can create your own little rulers with scrap pieces of paper. And so you're going to hold it up there, and what I'm going to notice is that between X and Y, it's 2 kilometers. And so that was the entire like example they gave you was 2 kilometers. So you'd put that up there, and then so what would the total answer be? Like, do I put the 2 kilometers on top, or do I put the 80 meters on top? So according to our gradient calculations, change in field value goes first, and then over distance. So the change in field value was that 80 meters, and the distance was the thing that we used the ruler for. And so 80 divided by 2 equals 40, right? And 40 was our very first example, is A on our very first example. So that's how you calculate it. that's the very first time. I know it's kind of confusing. It's kind of hard for me to teach this way without it being live and interactive with you. But bear with me. If you have any more questions, like I said, reach out. So we're going to go through multiple other examples like on here. So example number 2 has everything wrote out. So Regent's problem wouldn't have these extra lines. Like you can write on the side on a scrap piece of paper like doing this, but let's go over this. So it says a stream has a source at an elevation of 1,000 meters. It ends at a lake that has an elevation of 300 meters. If the lake is 200 kilometers away from the source, what is the average gradient of the stream? So first, we know something is it starts at elevation of 1,000 and the elevation now at 300. So the difference between those two are, I'll let you think about it in your head, 700, right? So 700 is the distance, the field distance change. So that's going to go on top. And then it says it is 200 kilometers away. So that's the distance that it is away. So now I have to take 700 divided by 300, divided by 200, which should equal what? So the answer is C, exactly. It should be 3.5 meters over kilometer. So you have to remember that you need to carry the units up there. And so the units were different on here. The units on the denominator were, the units up top were meters, and then the denominator, it was kilometers. So you have to put meters over kilometers. They sometimes will trick you. They'll have different units, and they want to make sure that you are still playing around with those units. So that would be example 2. So you guys will have practice problems like on this. You'll have mini practice, like multiple of them, and it's just doing the same thing over and over again. It's you getting used to like subtraction, essentially. And then, let's see, I'm going down this worksheet. What else do you need help with? So also on here, river flow. So you guys are going to be doing direction of river flow. There's a very easy way to cheat this is if you look at a contour map, you'll see like lines that go across. And then the rivers flow in the opposite way that the contour lines. So if you have 2 contour lines going like this, they're going down over and over again, these contour lines, and you're going to know what I'm talking about if you're looking at this sheet. They look like they're in this arrow formation. So if the arrow's pointing up and there's a line going down through this arrow, that's the stream. The stream goes in the opposite direction of the arrow. So if this is north, it's pointing north, the stream is going south. So if the arrows are pointing this way, the stream is moving the opposite of where this arrow is pointing. Okay, that's a cheat. That's how it always moves. The stream never moves in the other direction, and that's just because streams move downhill, like because gravity pulls water down. That's what makes streams move. And so if you ever see an arrow, just know that the stream there's a line going right through this arrow. The stream is always moving the opposite direction. Okay, so that is one of the other things. Let's see. What else could you guys get confused on? Those are pretty much that's pretty much the mini lesson for today. Everything else it's going to be hard unless you just call in and ask me questions. So feel free, once I said, hit me up on Google Hangouts. Just type in M. Kelly or Michael Kelly in Hangouts, and it'll go directly to me. And then I'll be able to help you out. And then we can set up a time that I can do one-on-one and then answer each specific question.